Today we continue our logic unit with conditional statements. A conditional statement is simply any sentence that can be, it's not always already written this way, but can be written in the form if P then Q. If P happens, then Q happens. Or if P is true, then Q is true. Most of the time when we think about these in common language, there are things like if this happens, then this other thing will happen. Your parents do these kind of things to you, well, probably on a pretty regular basis. If you clean your room, then you can go out with your friends tonight, right? Those sorts of things. Or it can be negative. You know, if you don't clean your room, then I'm going to ground you for a month, right? They can take the form of a threat. If you say that to me again, I'm going to pop you in the mouth. Right? There's all kinds of things that can be conditional statements. In math, conditional statements are usually not time-based. They're usually, if something has this quality, then it also has this quality. For example, if a rectangle has all sides congruent to one another, then it's a square. Right? Or if using rectangle still, if a quadrilateral, which is a four-sided figure, has four right angles, then it's a rectangle. Notice on those, it's important that you have them in the right order. Okay, sometimes it doesn't matter, but sometimes it does. Let me give you an example. If it's a square, then it's also a rectangle. A square is a type of rectangle, but turn it around and it's not true. If it's a rectangle, then it's a square. That's not true. Okay, so order is important in these. So once you've written it in if-then form, the phrase after the word if, after. Everything after the if is called the hypothesis. And the phrase after the then is called the conclusion. The hypothesis does not have the word if in it. The conclusion does not have the word then in it. It's what comes after that. So, here let's identify the hypothesis and the conclusion in each conditional statement. So, if today is Thanksgiving, then today is Thursday. By the way, true sentence. Notice if I reverse, if today is Thursday, then it's Thanksgiving. Is that true? No, they don't have the same truth value. So the hypothesis today is Thanksgiving. Conclusion. Today is Thursday. For the next one, notice the if here comes in the middle of the sentence. So the hypothesis is what comes after the if. Now, we don't usually when you have a pronoun like it, his, hers, theirs, whatever, we usually, when we write out the hypothesis, we replace it with the noun that it stands for. So it is talking about the angle. So an angle has measure (130 degrees). Conclusion An angle is obtuse. So, that makes sense? Now, we'll often write these in symbols. So, if P then Q, where P is some phrase that is your hypothesis and Q is some phrase that is your conclusion, is written this way: P and then this arrow and then Q, which is read P implies Q. If P is true, or if P happens, then Q will also necessarily be true, or Q will also happen. Again, sometimes this is based on time. Once P happens, then Q will follow. In geometry, most of the time, we're trying to say if it belongs to this set or it has this attribute, then it also belongs to this set or it has this other attribute. So this is a type of Venn diagram. Notice the V is capitalized because it's a proper name. I don't know what his first name was, but his last name was Venn. So this is how we would say, if it's a dog, then it's a mammal. If it belongs to the set of things that are dogs, then it also has to belong to the set of things that are mammals. All right, page 2. Sometimes there won't be an if or then in the sentence to kind of guide you, but a Venn diagram I think is helpful. This one says all succulents are leafless. It doesn't matter if you know what a succulent is. You're like, all of the things that belong to this group belong to this group. So all the succulents belong to the set of things that are leafless. So if they're in this inner circle, they also belong to the group of things that are the outer circle. If, and since it was plural, I would say if they. If it said it's singular, I would do if it. If they are succulents, then they are leafless. So for this one, if you already have the Venn diagram, I think it's really, really easy. If it belongs to the smaller set, then it belongs to the bigger set. If they are robins, then they are birds. Now, one of the things that we're going to look at is the truth value of a conditional statement. Conditional statements have a truth value of either true or false. And this is the part that bothers students a lot. They are false only when a true hypothesis has a false conclusion. If the hypothesis is true, but the conclusion is false, that's the only time a conditional statement is false. Let me give you an example. Let's say that I make the following conditional statement. If I win the lottery, I'll give you all $1,000. right? What is the only way that you can prove that I'm a liar? What has to happen?
You don't win the lottery.
If I don't win the lottery, can you prove that I was a liar?
No.
I told you what I would do if I won the lottery.
And you do win the lottery.
Yes, it has to be both of those things. I have to win the lottery. I have to have a true hypothesis, but then I don't give you the $1,000. I have to have a false conclusion. If I win the lottery and I give you $1,000, I told the truth. If I don't win the lottery, well, I could give you each $1,000 just out of the goodness of my heart, or I could not, and it doesn't make the original sentence false. This is one of the hardest things for students to accept. The only way you can have a false conditional statement is the hypothesis has to be true, but then the conclusion doesn't follow. What I said as my hypothesis, the conclusion doesn't happen or isn't true after a true hypothesis. All right, so let's take a look at each one of these. If the month is September, then the next month is October. True or false? True. If two angles are acute, then they are congruent. That's false. I want to give a counterexample for that. So to make a counterexample, I have to show two acute angles that aren't congruent. I have to make the hypothesis true, but make the conclusion not follow from it. So I'm going to draw a 30-degree angle, and I'm going to draw, oh, that looks about 75-degree angle. Make the hypothesis true, but don't make the conclusion true. Make the conclusion false. All right, so if 9 is divisible by 2, then pigs can fly.
False.
This is true. If the hypothesis is false, you can't prove that I'm a liar. If the hypothesis doesn't happen or isn't true, then you can't prove that this is not true. So since 9 is not divisible by 2, it doesn't matter what I write after that. Takes a little while to get used to this idea. Let's go back to one that I did earlier. Let's say, if it's a rectangle, then it has 4 right angles. And let's say I give you a circle. You're like, okay, since it's not a rectangle, I can't do anything with this. Just because the circle doesn't have any right angles doesn't mean my sentence was false, does it? Okay, now, the negation of a statement either adds or takes away the word not. So if a statement is, I am tired, the negation is not, I'm peppy, I'm happy, I'm whatever. It's, I am not tired. If you have not in it to begin with, the negation takes away the not. You are not slow. The negation is, oh, no, you are slow. All right, page 3. So there are 3 related conditional statements. The first one is the converse. The converse of a conditional statement switches the hypothesis and the conclusion. So you're just switching. The inverse of a conditional statement negates the hypothesis and the conclusion. So it either adds or takes away not from both the hypothesis and the conclusion. And then the contrapositive both negates and switches the hypothesis and the conclusion. Honestly, somewhere in my brain, the way I remember contrapositive is it's the long one, it's the one you do the most stuff. I have to have things that help me remember things like that. Now, converse and inverse, you just have to memorize that. All right. So, if an animal is a cat, then it has 4 paws. Write the converse, the inverse, and the contrapositive. Find the truth value for each and for the original. All right, so for the original, we will, not consider exceptions like, this cat had a leg amputated or whatever. Generally speaking, if an animal is a cat, then it has 4 paws. True or false?
True.
True. All right, so now let's do the converse. So I'm going to switch the hypothesis and the conclusion. So if, notice it says it here, that's a pronoun, so I'm going to put what the pronoun stood for, an animal. If an animal has 4 paws, then, and then I usually, because in English it always feels weird to say it first. You can go ahead and say it, or you can say the animal. Then it is a cat. True or false?
False.
False. What would be a counterexample to that? A dog, right? It has 4 paws, but it's not a cat. The hypothesis is true, the conclusion's not. The inverse. So I'm going to negate both parts. So I started off with if an animal is a cat. So if an animal is not a cat. Then it does not have 4 paws. What's the truth value of that one?
True.
False.
This is false.
Duh.
And the same counterexample works, doesn't it? A dog is not a cat, so I made the hypothesis true, but it does have 4 paws, so I've made the conclusion false. And then the contrapositive, I want to do both. I need to negate and switch. So if an animal doesn't have 4 paws, then it is not a cat. True sentence. Again, we're making exceptions for animals that were born with some deformity or, had an accident or something.
Look at yourself. Look at yourself.
My mom went to a store once and then she saw a bird with only 1 leg. It was just hopping.
On its one leg.
Yeah.
Birds can actually survive with just one leg.
I saw that in my backyard.
All right. Logically equivalent statements are statements that have the same truth value. So, a statement and its contrapositive always have the same truth value. If the original statement was false, the contrapositive will also be false. And the inverse and converse of the same statement always have the same truth value. Now, they can all be true. They can also all be false. But what happens a lot of times is you've got the original statement, let's say, is true. The next two are false. The contrapositive is true again. Or the original statement is false. The converse and the inverse are both true. The final statement, the contrapositive, is back to false again. Tonight's assignment is a lot of writing. If you would like to type it instead of write it out longhand, I don't normally accept that for the things that we're doing, but for this assignment I will. Okay? Because it's a lot of writing. All right? Any questions?